Hello everyone and welcome to Core Protocol Sync. We'll be sharing recent updates on the developments for the core protocol and related things and also plans for the immediate future. And as usual, Shamil will help us to start.
Sure. Last couple of weeks, I worked on the request batcher for Node. I reviewed code from Nazar for the P2P request rate limiting. And the main part was Kademlia pool model. Request batcher for Node, similar to Farmer's batcher, was a performance boost for Kademlia requests. Also, this week, I encountered several Kademlia issues from the upstream repository, the P2P. First, publishing provider is unlimited in current implementation. That causes issues on receiving peers. So we could expect multiple errors like inbound streams broken. And this error was commented by maintainers of the P2P, and they accepted it as a bug, and probably we or they will fix in moderate priority. Another issue from Kademlia that local providers iterators is incorrectly collected to the vector. In simple words, it is suboptimal implementation, which could cause probably some memory issues. Also, it seems that with the last version of the P2P, which is 0.50, get providers methods behavior changed since the last upgrade, and it returns a lot of duplicates. I'm not sure how we will handle that, but we should do that. We should do something with that. Also, probably the main part of my work was Kademlia pool model changes. I changed multiple components, including provider cache on boot node, piece and provider caches on the node, pieces and provider cache on the farmer, object cache populating algorithm, piece publishing and receiving algorithms. It was quite a huge work. And I finished it just today. I debugged a couple of days for some deadlock. This change will enable more performant and more, let's say, more efficient way of using our DSN. It's currently in our current implementation in master branch, we on receiving piece on farmer, on when with get piece on the node, we publish on DSN the whole piece. And now we will publish on that message that some piece has this node. It's just announcing of peer providing that's the piece. So that message will be probably 100 times less than the piece publishing as a whole. And that receiving piece, which mostly farmer, will request for the piece directly using request response protocol. So in theory, that should optimize our network a lot. So this was my main part of the last 2 weeks. That's it.
Awesome. Any questions?
What are you going to be working on this week, Shamil?
I expect a lot of comments from guys. So I will mostly support that. After that, if I have time, I will probably switch to the AutoNAT protocol for the NAT traversal algorithm. This one possibility. Another one is collecting data for the future block importing feature. We need to do some research on that. Most likely, it will be the first one.
Okay, so currently we have sync the farmer supported, but we're still working on sync the node from the DSN.
Yes, we have restored our proof of concept from the DSN v1. It works now, and now we need to get the requirements for actual block importing. I think we need some call with Nazar describing how exactly we want to import those blocks. So that importing process from the DSN is basically known now because it works now. But we need to do how exactly we do, how many blocks we need. Should we get some queue of the last several blocks? Probably we will take the last several blocks in different algorithm, request response protocol, something like that. We need to establish some requirements for this process.
Nizar, do you have time to sync up with Chanel on that this week or early this week?
Yeah, I think so.
Okay.
Or if it is a priority, because
That is a priority.
So it has more. It has more priority than that task with NAT traversal.
NAT traversal is nice to have. So resolving the farmer's dilemma is critical for us getting into the incentivized portion of Gemini 3. So we need to make it so that we don't need to run archival nodes, so that the DSN can serve as the archival network.
Okay, then we will collect that requirements. Okay.
Yeah. Okay. Shamil, with all these recent changes you've been doing with the pool model and some of the other things over the last few weeks, how much of that is reflected in the current the Notion documentation on the DSN v2 architecture?
It is, I believe, almost accurate, because we only changed to the push model because of the limitations of previous versions of Kademlia. So it was just a temporary solution, push model.
Okay, if you could just review that one more time, just go through it and for accuracy and make any modifications to that. I'm going to be reviewing that over the holidays to try to give you some guidance on what we can do for the next iteration, some of the open questions on the DSN. So the more accurate that is, the better feedback I'll be able to give you.
Okay, I will do that, but I'm pretty confident that it's up to date.
Okay, that's great. I just asking if you can just take one more check.
Sure, I will do that.
Okay. Thanks, Shamil.
Okay. So I guess those were all questions. On my side, which is kind of related, there were several pull requests. Not all of them are merged. So there was this one first, which has introduced limit for publishing concurrency. The basic problem was that initially we had block import blocking on the node by publishing, and that was like super slow. Everyone was thinking it was stuck, but it wasn't. We have fixed that by moving those publishing tasks into the background, and the same we did for the farmer. However, that introduced another problem because publishing was still slow. However, we were able to move forward quicker. And what that meant is that on the farmer, if you have a very big plot and you are plotting a lot of sectors and you are publishing all of those sectors, and they are publishing very slowly, that uses a lot of memory. Because all of those background tasks, they are still running for a very, very long time. And it can use like 100 gigabytes of RAM easily until those tasks actually complete. So what this pull request did, it actually introduced limits on how many sectors or how many segments we can actually publish, segments on the node and sectors on the farmer. So we have some bounded amount of memory that we are using. And if we are hitting that limit, we will actually pause plotting or the block import pipeline. That's why we may have seen that the node like kind of stops syncing. That might actually be related to that effect. So that was necessary to limit memory consumption. Any questions or concerns about that one? Okay. There was also a substrate upgrade. I don't think there is much to tell about that. You can go see the pull request if you want details. There are a few details there, but mostly we're just following upstream. And the big one, which is not merged yet and kind of blocked by upstream requirements, is this one. So we had these different limits in different places, and it kind of sort of works, but not really very well, because all of those limits for publishing of pieces and other things, they're in different places. They're not really coordinated. And what we need to have some kind of global limits so we don't hit the limit of a connection and don't drop the connection because of that and don't break it. So this pull request basically introduces those global limits for all kinds of connections for Kademlia specifically, and theoretically it should work. However, there are some problems with libpeer-to-peer itself where some of the internal mechanisms for the stream creation and destruction are apparently not deterministic. So when we think stream is destructed and can be reused, is not always the case. And what that means is that we are still hitting many of those limits, even though we're not supposed to. I have created discussion upstream in the peer-to-peer. I don't think if I have the link in the discussion. There is. The very last comment, there is a link to the discussion. Basically, they acknowledge that there could be some improvements, and they have already plans for the back pressure in the peer-to-peer itself. I'm not sure we need the whole back pressure. We just need to know when things are destroyed so we can actually control that. So I'll be joining the peer-to-peer community call tomorrow. It is Rust specific, and I'll discuss with folks. Maybe I'll take over implementing that in the peer-to-peer or fixing some things. But basically, they're open to improvements in that area, and that's something we need to actually make it reliable and performant. Otherwise, we are either have very, very, very conservative limits and it is slow, or we have optimistic limits and we are just destroying connections all the time because they are breaking. None of those are ideal. We want to actually be like right on the edge, but not crossing it, basically. And this will be very important to things that Shamil is doing and some of the other developments. I guess for more details, you can go to pull request and maybe have any other questions.
If you're finished with your updates, and sorry, I did have a question. Yeah. Do we have any kind of benches for the DSN similar to what we have for the consensus V2 for like plotting and like solve time and all that, like for syncing syncing the plot or like throughput, like network throughput, anything like that?
The benches we have are decoupled from the networking. So they are only benching whatever farmer is doing. Networking is kind of added on top, and we don't really have benches for the networking part yet. And that will also depend heavily on the topology of the network. So like if you have 2 nodes, that's one thing. When you have like 100, it's slightly different. So that is something we definitely should have at some point.
Okay, thanks.
Okay, I think that's it on my side. Daria, what about research?
Well, I could give a brief update on our latest developments. If
Daria, I think it would actually be really helpful if maybe you took about 10 minutes and just opened up the latest Notion document that you put together and just walked everybody through kind of the latest construction of V2 consensus at a high level. I think it would be helpful to keep everybody up to date on that.
Okay. Sorry, this is not the latest document. So the thing about latest construction, there is this concept that Chen invented called storage coins, which are not actually coins in like cryptocurrency sense, but it's basically just how to make farmer plots unique. There is a lot of been written here. So basically the construction that we are looking the most now is basically you determine the pieces you need to sync from the network. How exactly you're doing that, either the way it is done right now, or we can have some other way. So a farmer has some set of assigned pieces that they have to plot. They download those pieces. For simplicity, I've just used that the the sectors that the farmers are plotting are just the same archived segments, which is easier to describe, but it can work with a random selection of pieces. So the farmer plot downloads those pieces, puts them into a matrix. Basically, each piece will have a commitment, and you imagine each piece as a row of a matrix, and then you have a column of commitments. So this matrix has size of the rows are as many pieces as they have, and the columns are as many of 31 or 32 byte chunks each piece have. So if pieces are like 1 megabyte and you have 128 pieces, so you're going to have 128 rows, and like 32,000 columns. So it's a very disbalanced matrix, so you can say. You calculate a sector commitment, which is the commitment to the hashes of commitments. But this is part that I'm working heavily on again to find maybe a better way to do that. But for now, it's like that. Then you go to a creation of this unique plots called storage coins. So basically what they are is you generate in some verifiable way, maybe like with a KDF, with a key derivation function, or with a hash that you get solved, a list of IDs of coins, just a list of points. And you take all these polynomials that you have for pieces. You can see in this picture on top, there is F0, F1, F all the way down. And you evaluate each of these polynomials in those points that you have generated with the KDF. This conceptually creates an erasure coding of those pieces, but not on a consecutive, just like normal Reed-Solomon, but unique to every farmer. This has an advantage of that from these things, you can get back the original pieces, and it will have the same efficiency for every farmer, but it will be unique for every farmer. So it's going back to all the ideas that we have with erasure coding proof paper and the things that we have been discussing a lot and studying. So you generate a certain amount of those additional columns, what we call them storage coins. You can imagine them just the column vectors. The default value that we're thinking now is just to generate them as many as was your source data, so that you prove a replica is 1-to-1. And that would be a farmer replica. And you will have as many of these plots as you can fit, and they all will be equal sized. So it's not like if you have 10 gigabytes, you're going to have one huge matrix that is 10 gigabytes. You're going to have probably more metrics that are lesser size. But again, the exact numbers we are still measuring out, so to say. So your replica will be this sort of an erasure code on some unique set of points for each farmer. And the audit will keep the same structure as we have. So there is some global challenge. You're generating a local challenge by signing the global challenge. You are generating a challenge for each one of your sectors by hashing it. The local challenge was the sector index. And from that, you are deriving an audit index. So for each sector, you're reading only a single chunk or a few chunks. That's still something that we're deciding. You're not reading the whole sector to solve a challenge. You're just reading some specific address. And you construct a KZG proof that this one chunk, let's say this F1 ID that's on this picture, is a correct evaluation of at this unique point of this polynomial that belongs to piece. So you prove that, and that this piece belongs to your sector commitment that you have computed. And because these pieces are pieces of history, you can easily prove that that evaluation is actually a part of history and a part of some piece. So this is pretty similar in a way though to what it is done now in the prototype. But in the prototype, we're just erasure coding, we're evaluating on the one set of generator points for plotting, and this will make them unique for every farmer. But we still do have a few open questions with this construction, namely, what is the best way to calculate this sector commitment and possibly make it public? What to minimize the amount of communication and computation that we have to do, and what is the maximum size of this data metrics that we can erasure code, or maybe what is the optimal size for a sector to plot, whether it should be small so the proofs are faster, or whether it should be bigger. And we are still looking at, we may need to apply a slower encoding on top of this computation, because it's kind of too fast for protecting from on-demand encoding attacks. So we're working on that heavily. It's kind of, I assume there are going to be a lot of questions. To whether we want to go in depth.
It's usually either
Thanks.
a lot of questions or no questions.
Or no questions because nobody understood it. Because
no,
I'm just
thank you,
going too
Daria.
fast. Sorry.
That was a great overview. And Daria and Chen have been working really hard on this over the last few weeks. I think the key takeaway, maybe in really simple terms, is that before everybody was creating the same erasure coding of the source data. And there's a way that we can manipulate the evaluation so that we can have unique erasure codings of the source data. That's kind of the high level takeaway. Once we do that, there's more sophisticated things we can do using polynomial commitments and the relationship between polynomial commitments and erasure coding. And we're still trying to figure out the exact way to do those more sophisticated things so that they're efficient, efficiently verifiable, efficiently provable. We can make the scheme work right now. It just doesn't have the desired efficiency that we're looking for. And this is what we're iterating and tweaking on right now.
I have a question for Daria.
Mhm.
So the Ethereum dank sharding uses this polynomial and two variables, right? And it does a 4x times erasure coding. So is it this function here? Is it single variable or two variable that we use here?
So in this document, there are two constructions. One is using two variables. One is using a single variable. However, the construction with two variables is less efficient because you need to read the whole polynomial, so the whole sector, into memory to construct a single proof. That's quite a lot. So that would require making it smaller. And that makes the proofs bigger, that sort of commitment that I'm looking at, to be able to commit to those commitments of those bivariate columns. And yeah, that's basically the best way to describe it. But if you are interested about the bivariate construction, there's this first scheme in this document is using the two variables to the commitment scheme in two variables. But this is something that I'm still exploring, whether for this commitment to use a set of single variable polynomials or one big two variable polynomial. And there is also a discussion here in this document, if you want to read about what are the pros and cons to each of those approaches. Still undecided.
Great, thank you.
Awesome. Thank Daria. That is like really hard math that they are working on, and kind of on the bleeding edge of like what's possible. We are kind of mixing, matching different approaches with whatever we invented into a new protocol. Hope to have that work complete sometime soon.
Me too.
Yeah. Okay, Rahul, you had contribution in the pull request last week, and maybe you can share what you've been working on and what are your plans.
Yeah, so I'm still kind of onboarding, reading through documents. Last week, mostly I focused on David says course notes on the scalable blockchain design. So So I was mostly focused on that. And then today I have a meeting with Jeremiah to figure out the next concrete steps. That's mostly on the onboarding side. Apart from that, I kind of started to set up my dev environment and everything, and I helped Nazar with one of his PRs just to get a feel for the dev environment and stuff. That's mostly it. And I did a face-to-face chat with Nazar about some of the comments on the PR. I'm going to address it today and send a cleaned up version today, hopefully. That's it.
Awesome, thank you. That pull request is kind of nice in terms of the API. Just needed some cleanup, and there were some edge cases, but yeah, that would be a very much nicer way to do the same thing we did before. So thanks for that. All right, Lu Cheng, did you have any protocol changes recently? I don't remember.
Nope. I think what sort of sharing here, like mostly of them are pretty specific to the issues caused by the executor.
I see. Okay.
Lu Jing, there was an open issue at the end of last week. There was a GitHub TR debate over something with fraud proofs that you needed me to weigh in on. Did you guys resolve that yet?
And actually, apart from that problem, we actually ran into another new open question later, and I'll collect those problems into write-up so that we can have a proper discussion next time.
Okay. Yeah. Let's not wait because we won't have the next domain sync until probably 2 or 3 weeks from now. So yeah, just share that with me async, and I can try to give you feedback in the interim.
Sure.
I'm gonna have a
Sure.
lot more time over the next 2 or 3 weeks to work on protocol stuff.
Sure, I'll share it in the Slack once I
Thank you.
then. Yeah.
And kind of related to that, I was also having two separate discussions on Substrate upstream. One was the earlier one related to metrics. Basically, we have lib peer-to-peer metrics and we have Substrate metrics, and they use different libraries. We would like to unify them and have all of the metrics exposed at the same time, regardless of how many instances of Substrate we have with different prefixes or different labels, and lib peer-to-peer and everything basically to have unified system. It's still not super clear whether they would like to do that. They're kind of talking about dropping the library entirely and do it manually. I don't know. The other one was a little bit more productive, I think, so far, about RPC layer, because we have different domains and we need to create a port for each domain, and that's kind of annoying. And we would like to have some kind of scalable approach. And they have changed recently Substrate in a way that they have one port on which both HTTP and WebSocket RPC servers are running. It's the same protocol essentially under the covers, so it made sense to unify it, and they will deprecate two ports in the future. And it asked basically whether we can have sub-routes on the same server for different purposes. So let's say /relay chain and /parachain and one server. And if that is possible, then we can do /primary chain /domain-0, domain-1, and we can have as many of those as we need without creating a range of ports and causing complexity in managing of that. So that is something I'm trying to drive upstream. Maybe we'll have to do some contributions or refactoring there. But so far it seems promising. They do see value in that. And I think that will be something we'll be working on in the coming weeks and months with Substrate folks. And it kind of goes back to the unifying of networking layer, we will converge at some point all of those different things together. Okay, Nick, do you have anything to share on the core protocol side this time?
No.
Okay, that's easy. Ivan or Ozgan, do you have anything you need from us on the core protocol side or any issues except the sync process that gets stuck at block 1043?
Nope, just following updates. I will see, I guess, with the Gemini 3B.
Yeah, and what is the expected date of the DSN bug fix, Shamil, for faster plotting?
I mean, it is a little bit open question right now, I think.
Okay, then.
I had a question about the networking DSN that was possible to unify. I'm not sure, Ivan, if you completed that piece of work.
Yeah, it's done. It's working. Yeah, like I was actually able to farm like to sync and farm like the block on Gemini 3B with like shared networking instance for both Node and Farmer. So everything's good to go, I guess, for the release.
Okay, awesome. Can you share pull request with me? I don't know, in DMs or somewhere, so I can look into how it was implemented, just to make sure we don't have any edge cases there.
Yeah, we'll send you.
Okay, thanks. Anything else we are missing that we should discuss before we stop recording?
Jeremy, did you want to cover that bug we were discussing on the dev sync?
The 1043. You want to discuss that now, Nazar?
I mean, we can. I have not done any debugging, but so far it seems like we are just hitting that number of parallel sectors published on the node. And it just takes a while for them to publish. We need to figure out why, because it supposedly should be faster than before. But maybe there is something somewhere that prevents that from moving forward. I guess enabling debug logs will help. But I didn't have a chance to look into it yet.
Okay. I do think we should, track that down. Try and focus somebody's effort on that today, because it will make for kind of a weird user experience for the farmers getting set up. So,
Jamil, maybe you can look into it. You're pretty familiar with how networking works. Just try to see if you see anything strange on the DSN side.
Okay.
Okay. Lucian, you also mentioned that there is something on the verification layer on domains. Is that blocking us?
With a quick look on the log, now I think it's probably because the domains doesn't fork on the primary chain fork somehow. So I need to look into that. So I believe I have to figure this problem out before looking into the other symptoms, because it's kind of more fundamental.
Okay, see. I thought we are just following the fork choice rule from the primary chain.
Yes, it was supposed to work that way, but somehow from the log, I didn't see it reorg according to the primary reorg. So
I see. Okay. I'm sure we'll figure it out soon enough. All right. Thanks, everyone. It was another productive week for the team, or 2 weeks, I guess. And what day today is? Yeah, I think the next meeting will be in the new year. So happy holidays, folks, on YouTube, and we'll see you in 2 weeks. Bye.
Right.